In this clip, we're going to take a look at anti-differentiation technique like we were doing in class. In this case, actually, I'm going to take another look at this one. In class, we had a negative sign that seemed to be misplaced, but actually it wasn't. It's just the computer algebra system was showing it a little bit differently, and I'll kind of show you what I mean here. So let's go through this one again. Suppose I want to use u-substitution for this particular integral. I'm going to say, let's let my u be 8 minus 3x. So my du is going to be minus 3 dx. Problem is I don't have a minus 3 dx, I just have a dx. So what I'm going to do is I'm going to put a minus 1/3 out in front. And I'm going to put a minus 3 dx here, because the 1/3 and the minus 1/3 and the minus 3 cancel each other out, meaning if I multiply them together I just get 1, so I get the same thing. So as a result, this thing right here really represents my du. So what I end up getting is minus 1/3 the integral sine of u du. And if you recall, the antiderivative of sine is minus the cosine, so this is minus 1/3 times minus cosine of u plus c. Now when I substitute u back in, I get minus 1/3 times minus, that's times, minus cosine of 8 minus 3x plus c. The two negatives cancel, giving me 1/3 times the cosine of 8 minus 3x plus c. And if you recall in class, we were trying to check this with the computer algebra system, and it appeared like there was a problem, but in reality there really isn't. Let me show you what I mean. So let me add a calculator page here, and let's take the derivative. With respect to x, tab over here, I've got 1/3, put a fraction in here. Where's my fraction tool? So 1/3 times cosine 8 minus 3x. And I should get the answer we came up with, but it appears I don't. But in reality, it really is. Notice that here I have a minus out in front, but that's because it switched the order of these two. Instead of 8 minus 3x, it's writing it as 3 minus 8, the 3x minus 8. And if you recall, if I, in general, sine is an odd function, so the sine of the opposite of x is the same as the opposite of sine of x for all x. Okay, because it's an odd function, it's symmetric about the origin. So in reality, these are equivalent things. All I just have to do to show it is I can say, what if I type in the sine, go up and grab this guy, and say equals, and let's type it the other way, sine of 8 minus 3x, and hit enter, and it says true, because these things are equivalent to each other. Because if I switch the order of the subtraction, it changes the sign. Okay, so that's the big deal. So it really wasn't incorrect. It was correct in class. It's just I wasn't paying close enough attention to realize that the computer algebra system had switched these two things inside. So anyway, there's another example, just refresh from what we did in class.